On May 21, 2026, the Chinese government abruptly halted the export of a $2.9 billion shipment of industrial machinery. The transaction in question was a massive procurement deal between the Chinese supplier Suzhou Maxwell Technologies and Tesla. This equipment was the logistical foundation for Elon Musk's goal to build 100 gigawatts of domestic solar production capacity by 2028. Halting these shipments effectively suspends Tesla's expansion, stalling the domestic manufacturing timeline before a single panel has even been printed in Texas. The United States has a clear industrial strategy: build a complete, vertically integrated solar supply chain strictly within its own borders. To achieve that independence, domestic manufacturers must first purchase the highly specialized machine tools required to build the panels, and those tools come almost exclusively from China. Elon Musk himself has pointed out that heavy U.S. tariff barriers, intended to protect domestic manufacturing, end up making the deployment of solar artificially expensive. Beijing has recognized this vulnerability and shifted its strategy from exporting finished solar panels to acting as an upstream gatekeeper. Chinese firms currently control over 80% of the world's solar panel production, along with the manufacturing equipment supply chain required to make them. Beijing has positioned itself as the controller of the industrial machinery required to manufacture power, dictating who is allowed to possess the tools of generation. Tesla's solution to domestic production is a planned solar gigafactory located in Brookshire, Texas. The footprint of the site is massive, spanning 1.65 million square feet of industrial space. Reaching a 100 gigawatt capacity depends on the installation of automated, clean-room-grade environments capable of processing raw polysilicon into finished modules. This diagram shows the 4 specific categories of manufacturing tools required to make this happen: screen printing lines, plasma-enhanced chemical vapor deposition systems, PVD sputtering tools, and complete turnkey production solutions. All 4 are currently trapped by the Chinese export ban. Without these exact upstream tools, a multi-billion-dollar factory expansion is paralyzed, leaving an empty warehouse. The specific process these tools execute is called heterojunction technology, or HJT. Unlike standard solar cells, an HJT cell uses a highly specific sandwich architecture. It places a central crystalline silicon core directly between ultra-thin layers of amorphous silicon. This structure significantly reduces energy loss of the boundaries, allowing the cell to consistently surpass a 24% energy conversion efficiency threshold. HJT is also the mandatory base layer for the next major leap in the industry: perovskite tandem cells. When a perovskite layer is stacked on top of the HJT base, the conversion efficiency spikes to a record 32.5%. Manufacturing this architecture requires extreme mechanical precision, specifically the low-temperature screen printing of conductive silver paste. HJT is the absolute technological prerequisite for remaining competitive in the next decade of solar energy. Control over its manufacturing process represents a critical national vulnerability. Suzhou Maxwell Technologies is the undisputed global gatekeeper for this specific manufacturing equipment. The company commands over 70% of the high-end screen printing market globally. There are a handful of Western equipment alternatives, such as Germany's Singulis Technologies. However, the consensus among industry experts is that these non-Chinese alternatives are several generations behind in their ability to deliver gigawatt-scale turnkey manufacturing capacity. Compounding the equipment blockade, Beijing introduced a secondary strategic maneuver in January 2026, strict export licensing on silver. Silver is the most conductive metal, and it's nearly impossible to substitute in the high-efficiency HJT screen printing process. This graph shows the market reaction. Following the export controls, silver prices nearly doubled, surging from $38 an ounce to over $74. The Chinese government is executing a calculated double squeeze. They are banning the export of advanced printing machines while simultaneously restricting access to the highly conductive metal those machines need to function. The blockade of Maxwell's equipment is a direct act of retaliation within an escalating global trade war. It follows aggressive moves by the United States, including 50% tariffs on imported solar cells and severe restrictions on the export of advanced semiconductors. Beijing laid the legal groundwork for this counterstrike in April 2026, passing the Regulations on the Security of Industrial and Supply Chains. The core mission of this legislation is explicit. It prevents Chinese industrial champions from inadvertently helping foreign nations reduce their dependence on Chinese supply chains. The equipment blockade is driven by a deep concern over the dual-use applications of HJT technology. High-efficiency solar arrays are critical for supporting strategic space assets and the massive energy demands of terrestrial AI data centers. The trade war has graduated from consumer goods to foundational infrastructure. Solar technology is now guarded by the state with the same intensity as weapons-grade materials. The geopolitical friction forces a new reality onto the global economy, the dual supply chain model. The global manufacturing network is actively splitting down the middle, separating into two distinct, isolated industrial loops. Forcing the duplication of these highly complex supply chains drastically inflates the capital cost of building solar infrastructure, while slowing down the speed of actual deployment. The push to onshore clean energy production in the United States remains fragile if the country lacks the domestic equipment suppliers needed to build the factories. The era of a highly globalized, economically optimized clean energy supply chain has ended. The global energy contest has evolved into a competition for the sovereign power to build the machines of production.